students, refraction on the earth we have seen. That is through the prism or any other medium like glass or any other things, water. So refraction is mainly the bending of light when the light is going to moving from one medium to another medium. That is clear. Now what happened? Because you know that light is not coming just from the above sky. Light is coming from the very far, crores of far distance. That is sun and the stars. They are situated a lot more distance from the planet. And while the sunlight and the starlight that are coming or entering into the atmosphere of our earth. So atmosphere again is having different density of the range. Because you know there are stratosphere, troposphere and mesosphere and variety of layers we are having. Atmosphere is just not a single layer. It is having different layers, and each and every layer is having different and its own density. Yes, so here our next topic is atmospheric refraction. You might be understood with the term atmosphere because we are having different layers, and that layer itself is causing the light to get refract from one medium to another medium. This one will be act as one medium, this one will be act as another medium, and the rest one would be except the different mediums. So this is atmospheric refraction, and this is the random flickering of the object, that is light that is coming from the very far. Have you heard about the twinkle twinkle little star? Yes. So twinkling is not like it is actually happening there into the space, but because of these layers we are going to see this light that is coming from the stars going to flicker like that. That is all due to atmospheric refraction. So here we are having several phenomena related to that. First of all, you can see that the apparent position of the stars. You know that the light that is coming from the lots of millions of far distance of the star that is coming towards this planet, and now that is entering into your eye. You are very small out of this galaxy, you know, and the light that you are receiving is very far from you. So now when it is going to entering into the environment, so as here you know that there are different layers that are present. So these layers are going to make the light get bent, and that bending of light is now coming into your eye. And now when you are observing this one, so it is not actually like you are feeling like you are seeming like that it is actually directly coming into your eyes, but actually it is bending, but you can't predict it is though it is bending or not. But our eyes and brain are working in such a manner that we see that light is not actually bending, but it is coming straightly from the place. Likewise, I have told you in case of the bending pencil. That is why it seems like it is going to bend, because we cannot predict that light actually get bends, though it is actually bending. So here this star seems like that it is actually situated at this position like here, but actually in reality it is present here. This is the original position, but because we cannot see the bending, so we observe ourselves that it is actually the straight line and it is coming from such a place. Now what are the next things, examples that we can see? Here twinkling of star appear higher than they are actually. That is this example. This is the apparent position, this is the real position. Even you will see the higher position because of the bending. You cannot observe that. And the advanced sunrise and delayed sunset, we are going to discuss that also. And flattening of the sun disks. Okay, so let us take this one example, that is the twinkling of stars. And before that, here you know that air in the upper atmosphere is optically rarer. How? Because you know space is not having any air or any kind of medium out of there. Yeah, correct? But while it is going to come, the first layer that we are getting and the light going to meet is optically rarer. Rarer means halka. Okay, that is not very dense. but while it is coming towards the surface of the earth, it is going to dense. So densing part is coming later. When the light ray is coming from the rarer to the denser medium, so what does happen? I have told you already that rarer to denser, that means it is bending towards the normal. Yes, so accordingly it will bend like a rarer medium to denser. So light ray is coming like this, and while it is meeting to the normal, like this is the point of incidence, and if we draw a normal here, so it is bending towards the normal while moving from rarer to denser. That is again happening here in case of this, because space is not having any kind of air object, and the atmosphere layer that is present nearby to the space is also a rarer. But while coming towards the down part, you will see that density is going to increase. Now, air in the lower atmosphere is optically denser. I have told you the reason. Again, now twinkling of stars. So, I have told you that twinkling is not actually being done there, but it is just the observable part, because sometimes the light that is coming from the star is not going to meet our eyes, and again it is going to get by our eyes, because you know that there are different layers. Yes. So light is getting bent. So one time it is going to bend like this, like this, like this. So optically denser, optically rarer, then denser, then rarer. It could be happen, and it depends upon the climatic conditions also. When the weather is so clear, then you will able to see all the stars, and they are not even twinkling. So why you do see twinkling stars is because the layers of the atmosphere is going to change their densing property. And at the time, light is going to make like this zigzag manner. So zigzag light coming out of, because it is going to bend again and again through different layers of atmosphere, and then it is going to enter your eye. That is why you see stars light like twinkling. Okay, so that is the basic reason of twinkling of star. Now advanced sunrise and delayed sunset. Now what is happening here? Like on the earth, you see that this, let's suppose this is the surface of earth, and you know that sun rises from the east and sets at the west. So let's suppose here we are having the sun. Okay, now the sunlight that is entering into the earth's atmosphere is going to be coming like this, but because of atmosphere, it is going to bend itself, and little bend make the light to appear at the position where actually the light is not falling yet. Because you know the surface that is in contact, that is facing the sun right now, is this one. Only this part of the earth must be getting the sunlight. But why this part of the earth is going to get that? Because of bending of light. That is why this light is going to bend, and the people here who are present here, who are living here, will appear that will see like that sun is actually rising up. So actually we have shifted the position of sun because we cannot observe the light get bent. That is why we see sunrise 2 minutes before to the actual sunrise, and it is for the all parts of the world. I am not just specifically saying for one part, but mainly you know that at the equator, because equator is the midline of the planet, and the portion, the countries that are situated at there, so they will keenly on the sharp time they will feel the exact time at the sun which is rising. So it is actually rising for them. But for the other parts, that is at the Tropic of Cancer, Capricorn, so light get little bent, and to that portion actually the sun is going to appear much more earlier, like 2 minutes earlier. And even because earth is rotating on its own axis, so little light on equator also you are going to observe 2 minutes before, because earth is going to rotate. Okay, so light at this position, so it will get light directly, but the person who is standing a little far from that position, a little distant from, like country, there is a country, and if this position is going to get the sun, and a little far position of that, from that position is also going to get the light. But because that light is coming, because the light of the sun is going to bend and observer will get this, and then we will see it like the sun is going to be rising up. But in the same manner, we see that when the sun is going to set, so here the sun is going to set, but when it is going to set totally like here, light that is coming from here again going to bend, and for the late 2 minutes you are going to see sun. So exactly for 4 minutes, 4 extra minutes, we are going to observe the sun before it is rising and after it is going to set. राइज होने से पहले से 2 मिनट एंड राइज होने के बाद 2 मिनट तक हमें सन दिखता है. So total 4 minutes extra we are going to take the sun. So this is how atmospheric refraction is going to work, and these are the practical examples for it. Let us see how does light scatter now.